So, Chapter 8, Forecasting, Part 6, we're going to go over how to measure accuracy. Okay, so this is the slide that showed an example of a capstone project I've done several projects that go into forecasting. So, forecasting is done regularly by any company. They need to know how much they're going to sell so they can prepare their inventory, their equipment, their logistics, their resources, and people, and train their people so they're prepared for variations in demand. We're now in a project with Continental Tires, for example. I'm working on a project that we are looking at their forecast process of retreads, and we kind of dig into the methods that they use and how can they improve that process. This was another capstone project we did with Cummins, an automotive company, and we looked at how they forecast containers. And we build for them these 1, 2, 3, 4 different methods. Okay, so this method here, the blue line is always the number of containers that they have the demand for over the months. We looked at 20 months, and orange line was a forecast method, right? So the linear regression model which we're gonna learn and use also has this was what it's predicting for the forecast. And we also use a 4 months moving average. This was the forecast, the 3 month moving average, and the 2 months moving average. So what I want to show this to you guys in this slide is that you can have very different methods, right? So which one was the good one? Which one is the best one? So every product can have a different method that works best for them, right? Depending on how the variation occur over a period of time. So there's a way to understand which one is the good one is to calculate what we call the forecast error. And with the forecast error, you can actually calculate the forecast accuracy, how good or bad it is, right? So think about the weather, right? So you look at your phone and there's always the weather there, how good they are in predicting, right? Are they always right? Are they always wrong? We always think they're always wrong because when they get wrong, we get really mad, but that's not the case. Sometimes, or most of the time, they're actually right. So, how to calculate error? So, errors is a measure that we're going to use, and it's a very, very easy math starting point. It's going to get more complicated over time. But error is basically demand minus forecast. What was the demand for that month? What was your forecast for that month? Okay, and that's how you calculate error. With error, you can calculate different measures. You can calculate the cumulative sum of forecast errors, which is just the sum of errors for every period of time. You can calculate the average forecast error, which is that cumulative sum divided by the number of months that you forecasted. That's n. You can calculate the mean square error. So you're just squaring that and sum all that and divide it by the number of times. So you have the mean of that squared error. Or you can have the mean absolute deviation where you're taking the absolute value. So when you calculate error, because it is demand minus forecast, you can get a positive number or a negative number, depending if your forecast was higher or lower than your demand, right? When you're doing the squared and you're doing the absolute, you cannot have negative numbers, right? So that's the absolute deviation here. You divide it by the number of different periods that you forecast, which is n. And finally, the one that we're going to use more, and that because companies use more and it makes more sense to compare products and methods with other methods, is what we call the mean absolute percentage error, which would take the mean absolute deviation here and divided by the demand, so that's the sum of the absolute error divided by the demand, and you calculate the mean of that depending on how many different periods of time you have. But it's giving you a percentage error instead of a unit error. Is a percentage error because it's demand minus forecast divided by demand. So it tells you what is the percentage of the demand that you got wrong, higher or lower. And it's always a positive because it's the absolute value. Okay. So this is an example table that have kind of look similar to problems and homeworks that we're going to encounter in the future. You have months, you'd have the demand that will happen for that month. It has the forecast that we calculated, and we're going to see the forecast methods in the future. But that's the forecast that we had for that month. And what we need to calculate is error, squared error, absolute error, and absolute percentage error, right? So error is demand minus forecast, right? So that's again, you guys know that we're going to get into this part where the math is really easy. Demand is 20, forecast is 22, error is going to be 2, right? Demand is 24 here, and the forecast is 22. So demand minus forecast, error is going to be 2. So the difference is here you have minus 2, and here you have positive 2, right? Plus 2. For this one is going to be 30 minus 25 equals 5, and then you guys can do the math, right? So that's our error. If we want to calculate the squared error, we take this number and just square it. So 2 is going to become 4, minus 2 is going to become 4, 5 is going to become 25, and so forth, so on, right? Oops. So here we have the absolute error. So we're taking demand minus forecast and absolute, and that's the absolute percentage error, right? So we're taking now 2 divided by the demand, 20, okay? And that gives us our absolute percentage error. 2 divided by 24, that's 8. 5 divided by 30, 17. 7 divided by 7. And what you do at the end is you get the mean. When you have the m at the beginning, that's the mean. Okay, so mean absolute percentage error 11%, mean absolute deviation 2.75, and mean square error 8.75. Okay, so what I want you guys to do now is to do this practice. What I want you is just to complete the table, right? So we have the month here, we have the demand, we have the forecast, and then you need to do the math to calculate the error, mean square error, mean absolute percentage error. Okay, so try to do that. Okay.